Hello everybody. In this video I will show you how to create binary source tree using Java code. First let's define the binary source tree. Binary source tree is a binary tree in which left children of the parent is always less than the parent and right children is always greater than the parent. Let's suppose these are the data given. Using this data we will try to create a binary source tree in picture first. So the first value is 55. So this 55 will be the root. Initially there is nothing and root is the first element. So we are making this 55 as the root. Now let's suppose 67 is the second value coming. So second value 67 is greater than 55. So we have to check whether there is empty position in the root, that is 55 or not. 55 has nothing in the right, so we can why this happens. So we can assign this 67 to the right of 55. Okay, so we can connect this by a line. Can make a connection. Now let's suppose another value coming is 6. Okay, 6 we will be comparing with the root. In this case 6 is less, so it should go to the left. The left part of 55 is containing nothing, so we can immediately assign this 6 to the left of 55. I'm missing the value here. Okay, I will type it instead. Okay, now make connection here. Now next value we are getting is 45. We'll again start comparing 45 with 55. Whenever we insert new data, we always have to compare this new data with the root. In this case 45 is less than 55, so it will go to the left side of 55, but there is a number 6, value 6 in the left of 55, so we'll compare this 45 with 6. This 45 is greater than 6 and there is nothing in the right of 6, so we will assign or place this 45 to the right of 6. Okay, now let's get this connection. Okay, now the next value we are getting is 32. 32, again we have to compare that 32 with the root 55. It is less than 55, so we have to compare 32 with 6. Again, now this 32 is greater than 6, so we have to check in the right side of 6. We are getting 45. This 32 is now less than 45, so we are supposed to store this 45 at the left of this 45. So make connection here. Okay, now the new value we get is 99. We again compare this 99 with 55. 99 is greater than 55, so we'll check in the right side. There is a node with 67 in the right of 55, so this 99 will be compared with 67. This 99 is again greater than 67, so we'll check whether there's empty position in the right of 67 or not. Okay, there is the empty position in the right of 67, so we'll place this 9 to the right of 67. In this way we can create the binary source tree, and binary source tree has a special feature. When we do Inorder traversal of binary source tree, we get data in the sorted form. In Inorder traversal, we first visit left node, then we visit tree, root node, then we visit right node. So using this pattern, we can get the data in the sorted format. Now let's start coding this in Java. First let's create the binary node. I have created lots of nodes here. Let's suppose node 2. Let's make integer data. The node of binary tree will have two parts, left and right, like in the double linked list. Let's write the constructor node 2, and this constructor will have parameter d. Let's assign d to the data. Let's assign null to right and left. Okay, that's the node definition. Let's make a node binary tree for int. Now let's define public static. Okay, this is usual thing. Now let's define some nodes. Okay, now let's define some values list, some list of values. We will be using these values to create this binary tree, binary source tree actually. Okay, now we'll be using these values to create node, and those node will be inserted to the binary source tree. Now let's see what we have to do is, okay, we'll be iterating through this list. For inti in list. Now using this value, let's create new node equal to new node 2. Let's pass this value. Now initial value of this list is 22, so the node will be created having data 22. Now let's check whether the root is empty or not. So initially root is null, so we'll assign this newly created node to the root. Otherwise what we do is we have to check left right of the root. So first, so let's make the temporary node as root. Now we have to check, we have to make an iteration first, not checking. While temp is not equal to null, now we will check if temp of data is greater than newly nodes data. That means newly nodes data is less than temp's data, so new node should go to the left of temp. So we have to check temp dot left is equal to null or not. Then if the temp of left is null, we immediately assign this newly created node to the left of temp and we'll break the loop. Otherwise we will descend down the tree by assigning temp equal to temp of left. Okay, in this way we finish the left part of this binary source tree. Now for the right part, what are we supposed to do? We will be writing the else part here. Else, now we have to check temp dot right is equal to null or not. If it is null, then immediately we can assign this newly created node to the right of this temp and we break the loop. Otherwise we will descend down the tree. So we have to assign temp equal to temp dot right. Very simple. Okay, now in this way we can create the binary solution. Very basic and simple logic. Now we'll be defining one function, that is the Inorder traversal. Public static void. We will be writing iterative method. My node is 2. Okay, we are getting the root here. Now what if root is not equal to null, then we'll call this method iteratively. First left, then we'll display the value of the root node. Data, then again we will call this method using the root dot right. Okay, I have to now binary tree in .java. If I'm correct, that finally binary tree. Okay, it seems okay. Okay, why I'm doing this? I cannot define function within a function. This will be the part of class. Okay, I have to take this here and let's resave this. Is there any problem? Let's check. Nodes definition okay. Binary public static void in order. There is no problem. I think now we have to call this method. Where is the termination of this for loop? Here. Okay, here we will be calling in order. Okay, we will be passing root. Everything seems fine. Now let's compile this. I have made a silly mistake by saving this file with a different name, so I changed and correct the name of file. Now let's compile this. Let's see what are the values here. I have not done any manipulation here. Okay, oh, it's called correct. No, not C here. Here Java C binary tree int Java. Now everything's good. Binary tree to int. Now let's compile. Okay, now you can see the values are appearing in ascending order. Whatever value I have provided in this, Now, using these values, we have created the binary search tree, and I've already told in the beginning, when we do in order traversal of this binary search tree, we will get data in the sorted order. Now, you can see in output the data is in sorted order. Now, I can add few more values or change value like this. I'll be adding 1000 here. I can add minus value 99. Let's save this. Now let's recompile this. Now you can see the data is coming in the sorted form. That means our binary search tree is created successfully. I hope that you understood it. Thank you very much for